computer. I just hope it knows what it's doing. Okay. So probably does. All right. So let me share my screen with you again. Okay. All right. So this thing is like goofy because okay. So what you have to understand is this is the heating curve. Like this is how they trick you here. Okay. Can you guys hear me?
Yeah.
Okay. This is how they trick you. So they go 1 mole this is the heating curve for 1 mole. The heating curve for 1 mole. And they ask you what happens when half a mole, okay, undergoes this transition. All right. So let's just go ahead and take like 60 more seconds to think through this thing. So 60 more seconds, and there are 2 of me on video. That's weird. Okay. Okay. So let's go ahead and take 60 more seconds to think about this. So hey Siri, set timer for 60 seconds.
Okay. Your timer is set for 1 minute.
Okay, so everybody's here. Everybody's here. Okay. So the second part of that is right, Antonio. The second part of that answer choice, but the first part is off. So I'll get the answers like written down. This is like 13. This is like 49. This is like 98. This is like 120. So that's what's going on there. All right. Okay. So oh my gosh. Okay. my you're like my wife sent me this meme. Like you got to see this. Like look at this. So it says, or is it? Can you guys see? Doggone it! It says.
Breaking Bad.
So I'll read it to you. Yeah, it goes like so. These are the guys, right? It's Breaking Bad, and it goes government work from home, and then it goes chemistry teachers and they're like right there.
There you go.
That's hilarious. Okay, what's up?
There you go.
What?
There you go.
All right, no, that is not where I go.
Great. I want a slice of that.
Kids,
A cookie.
Need to get in on that money.
Words of wisdom, okay? Heed these, okay? Stay away from illicit narcotics.
Yes.
All right. So, okay, so the heating curve for 1 mole, what happens when 0.5 mole undergoes the transition? Okay, so, all right, let's go with Idali. Idali, what'd you get for this one?
I thought it would be A.
A, okay. What'd you get for this one, Jacob?
I was thinking either A or B.
Okay, what'd you think, Antonio?
I got A.
Okay, Caton?
I got B.
Okay, so here's the deal. So you're going for 1 mole, you go from here to here, right?
Mm-hmm.
And that does look like about 98. So 98 divided by 2, because you're going with half a mole, equals 49, right? And so that agrees with this number here, and that's true. This sodium is absorbing energy to overcome the attractive forces between adjacent sodium atoms. Okay, so that's absolutely true. Okay, so B is correct. Any questions, scholars, about why B is correct?
No.
No? Okay, we're out. Okay, so number 13. Man, this is absolutely brutal. I'm like looking at this thing trying to figure out. Okay. So the enthalpy change for the reaction represented by the chemical equation shown above is, oh gosh, delta H equals something with an excess. Oh, you can't, how do you even do this problem? You can't even like see the, oh,
Goodness. Which problem number is this?
it's number 13.
13? Okay. I can share my screen briefly.
Does your screen show it correctly?
Yeah.
Go for it. You're the man.
Yeah, I think it's just yours, Dr. J, because mine
Yeah.
shows it perfectly.
Okay, everybody show this thing. Perfect. Can't see a darn thing.
It's disabled attendee screen sharing.
Yeah, you have screen sharing off.
Oh, there we go. Cool. Okay, so pay no attention to the man behind the green curtain there.
Okay, great.
Yeah. Here's the
Okay.
question. And while you're at it, you get to see the answer I think I got.
Okay, cool. So 2 moles of sodium, whatever that is, OCl, I don't know what that is. I should know what that is. Reacts completely with an excess of Na2S2O3 and Na is sodium hydroxide. Which the following changes occurs? Okay, so this is your thing here. Okay, so 2 moles of that completely with an excess of that and that. Okay, so there's 2 moles of sodium. Okay, yeah. Okay, 2 moles of this guy. All right, enthalpy occurs. Okay, and the delta H is -12. Okay, so, okay. Yeah, this is a really good question. All right, so give yourself 90 seconds to think through this. Hey Siri, set timer for 90 seconds.
Your timer is set for 1 minute and 30 seconds.
Okay. Completely unrelated to this, Dr. J, CO2 has 2 double bonds in it, right?
Yeah,
Okay.
there it is.
Perfect.
Yeah, I agree with C.
Yeah, I think so. Okay, so Italy, what did you get?
I agreed with Caden. I think it's C too.
Okay, you think so too, Symphony?
I'm kind of in between. I don't understand why.
Okay, so let's take a look, right? So this -1236 kilojoules per mole. So what does that tell you? Is heat being released or is heat being absorbed by the reaction?
It's being absorbed.
No.
I mean, released. My bad.
Yes. Okay. And then because that means that the enthalpy of the products is less than the enthalpy of the reactants, so it must be released. And then is this an endothermic or an exothermic reaction?
Exothermic.
Exothermic, right? So heat's being released, it's exothermic. Good. Okay. And then how much of this would we normally have? How many copies, how many moles of this NaOCl?
4.
4. You'd normally have 4, but then how many do we actually have in this case?
1, 2.
2. So we have half the normal amount, right? So 4 moles give this much. 2 moles will give half that much. So is C the correct answer?
Yeah.
Yeah. Okay. Heat's released and half of that much. Okay. Half of 1236 is released. Okay.
Okay. That makes sense.
All right. Any questions, scholars? Jacob, you good to go?
Yes.
Okay. Number 14.
Right. Cool. Oh, there we go. So this is the thing that sparked me going down the thermite rabbit hole.
Oh, fun. Oh, this is fun. Okay, yeah, do this. Okay, this is a simple grams to mole conversion. Okay, go for it.
For
Just
reference.
start. Okay, so hey Siri, set timer for 2 minutes.
Also, just as a heads up, aluminum has a molar mass of like 27 grams per mole, I think.
Okay, so aluminum. Okay, go for it, guys. Hey Siri, set timer for 2 minutes.
Okay, 2 minutes and counting.
Yep.
Not make the coffee very strong this morning.
Okay. All right. So what do we get here, gentlemen and ladies?
D.
D. Okay. Italy, what'd you get?
For some reason, I got like A, but that doesn't look right. So I don't know.
Okay. That's okay. So you probably did like 27 over 108 or something. So you start with Symphony, what'd you get?
I got D.
D. Okay. Antonio?
Yeah, I got D.
Okay. So let's take a look, right? You start with 108 grams. Okay. So you go 108 grams aluminum times 1 mole aluminum per 27 grams aluminum times negative 850 kilojoules per 2 moles of aluminum. Okay. And then these cancel, and you get D, 1700 kilojoules. Okay.
Hey, Dr. J,
Yeah.
are we leaving at 11?
Yeah. We're leaving at 11. Huh?
All right.
Yep. Okay. Any questions, scholars?
Nope.
Okay. All right. So do we have one more problem in us, or do we want to call it a day at this one?
I mean,
Sure.
shoot.
Let's knock this last one out then. Okay, number 15. All right, so the equation shown above represents an endothermic reaction between carbon monoxide and carbon, both gases. What is the amount of heat absorbed by 1 mole of carbon monoxide, or when 1 mole of carbon monoxide reacts with an excess of carbon gas? Okay, so 1 mole of carbon monoxide reacts with an excess of carbon gas, okay? Heat absorbed. Hey Siri, set timer for 1 minute.
Your timer is set for 1 minute.
So, Dr. J, I had an idea for a reaction we could do for thermodynamics, or
What do you
for
think we should do?
a lab for thermodynamics. So we could do like a Mentos and Coke style thing, and then measure
Yeah,
the
that's right,
change in
Antonio.
volume. What's that?
Mentos and Coke, and then I was talking to Antonio.
Oh.
He PM'd me with the answer. He got it right.
So- Yeah, you put Mentos and Coke, and then measure the change in volume against pressure, and use that to calculate the work done by the reaction.
That'd be fun. But you'd have to be able to measure the volume.
Yeah, I was thinking like put a balloon. Yeah, I mean, I guess you could just.
It'd be a small amount of Mentos and a small amount of Coke in a balloon. That'd be fine.
And measure the change in volume of the balloon.
Yeah, you'd also need to do like a Q on the back end. I don't know how much the temperature would change, if at all. I don't know what happens during that reaction in terms of temperature. Probably not much.
Mm.
But yeah, you could measure the work done. That'd be an interesting thing. So you could calculate the change in internal energy of the system. That'd be cool. Okay. All right. So, Idali, what did you get for this one?
I got B because it's asking for 1 mole, and then the delta H it's for 2 moles. So I just divided it by 2, so I got B.
B, perfect. Okay. So let's go through that from the beginning, right? So you get 1 mole. In fact, I think that's pretty good, guys. Are we all good on this one, or do we have questions about this? We can actually knock out. It's 10:57. I want to keep you guys longer. We could knock out another problem if we wanted to. We can save number 16 for tomorrow. So any questions about this one?
Makes sense.
This makes sense. And Antonio got it right. Kaiten got it right. Evalie got it right. Symphony, you too?
Yeah, I'm good.
Okay. Then I think we're all good for today. All right. So I'll go ahead and